All right, let's look at lesson 7 of chapter 4, talking about scatter plots. Another way to show relationships between two sets of data is to use a scatter plot. Basically, you put two sets of data together and you map them out on a grid, and then you see if there's a relationship that you can create or see with that data. So let's consider a concept here to maybe help us understand what a scatter plot is. Let's say we have a cold lodging, and we have data for that it uses sink ion availability, called ZIA, to measure the lodging's strength, and then it's data about how long a cold lasts. So we got two sets of data. We got the lodging strength and data about how long the cold lasts. So two different sets of data. So I'll call that ZIA and data about how long it affects. And then here's our data plots. Here's our data. If the ZIA factor of the one lodging is 100, we get 7 days shorter cold. If it's 44, we get 4.8 days of shorter cold. If it's 0, there is no shortness or change in the cold. If it's a positive 25, we get a negative 1.6 days. If it's 13.4, doesn't seem to be any change in the cold. Another 0 point with nothing. And if we have a negative 55 ZIA factor, we add 4.4 days to the cold. Negative 11 ZIA factor adds a day to the cold. So I went out there, and in these red dots right here, you can see them in the red dots. I plotted all of them on here, and I'll just make one green. We can take this first plot right here, 100 and negative 7, and if you come over to 100 right here, and you go down to negative 7 right here, there's the plot. Okay? And I did that with all of them. 44, negative 4.8. 44 is here to the right, negative 4.8. And so on and so forth. The only thing I'm going to point out is that we had two plots of 0 and none. And when you do that on the data, you want to put a little mark by it. And I marked it with a 2. Sometimes that's hard to do. Sometimes you might mark it with a note, and then later on the note say, this data point had 500 instances. Depends on what's going on. All right, so now I have all my green dots. I changed them from red to green. And what can I see about this data? Well, it appears that if I have a high ZIA count, if this is high, this 100 here, if it's high, then I lower my days of having a cold. And as the ZIA count gets to be negative or smaller and smaller, I am increasing the days of my cold. So it appears that there's some kind of effect here that I need a higher ZIA count in order to lessen my cold. And when you see something like that, that's called a correlation. Okay? Correlation is just a fancy term that describes the type of relationship between two data sets. Okay, and there's a couple different types of correlation: positive, negative, or no correlation, and we'll talk about that in a second. But when you have a data plot, scatter plot, one of the things you can do is put a line of best fit on it. What it is a line that just looks like it comes closest to all the points on a scatter plot. But in reality, it can be many different lines. How do you know how to draw the line? And what I'm going to tell you is you just kind of eyeball it, and you'd use a ruler. So I'm going to pick let's say a nice color there, and I'm going to use, instead of a ruler, I'm going to use my line drawing tool, and I'm going to start at that bottom line and make it come straight through. That looks like about as close as I'm going to get to everything, just like that. And once again, there's no real right answer as long as you're basically following the data, the points you have. If you take more advanced statistical measurements, there's mathematical formulas to create that line. But for now, just get a ruler out and draw a line that looks like it's the best fit. Okay, so now you can see that we have data here, and let's take a look at the types of correlation that we could have had in our data, and we'll come back and look at our lozenge and cold chart again to see what kind of correlation we got. So here's the types of correlation that we can have. We can have a positive correlation, we can have no correlation, and we can have a negative correlation. So we need to talk about what each of those three things are. First of all, if I have a positive correlation, that means both data sets, the one that I plot along the x-axis and the one that I plot along the y-axis, both of those data sets are going to end up being increasing together. So as they go up, as one data set goes up, so does the other data points. Okay, and if you were looking at this on a graph, that is a positive slope on that line. So both of these drawings have a positive slope. Now, when you're positive correlation, there's two subtypes. You can have a very strong correlation or you can have a weak correlation. Strong correlation just means that all your data points are pretty close to your line. Okay, whereas a weak correlation means, hey, they've jumped out. There's some further away. So you can kind of see that these two patterns, the pattern on the left here with the strong, this pattern, that's the data points are close to the line of best fit, or that red line that I drew. And on this one, they're not as close, so we call that a weak positive correlation. Now you can have the same thing on the negative side. I can have a weak or a strong correlation that is negative. All that means is that when I draw my line of best fit, I'm drawing a line with a slope, a negative slope. And what does that mean? It means as one of my data points, data sets, increases, the other one decreases. Now, negative and positive are not good and bad here. They're just terms for saying, are both my data sets increasing together, or are they going in opposite directions? Negative means they're going in opposite directions. Positive means they're both going up at the same time or down at the same time. Okay. And then there's the case where my points are scattered all over the place. And I can't really draw a line of best fit because what would that line of best fit look like? Would it be like here? No, that doesn't make any sense. Let's not do that. How about there? Well, what about this point and that point? They're way out there. Oh, how about go the other way? Let's see. Let's go this way. No, that doesn't fit either. That's the same problem. So basically what happens is if your points are all over the place, it's basically no correlation whatsoever. And what does that mean? It means that the changes on one data set don't affect the values on the other data set. So as one goes up, it doesn't matter what the other one isn't affected. It doesn't go up or down. It just has random spots. And when you get that, you kind of get points all over your plotting area. All right, so now let's take an example. Since we have these, we now know what a positive and a negative correlation is, or no correlation. Let's take a look at our data from above, and let's take a look at our lozenge chart. Well, this looks like it's a negative correlation because I'll give this a purple color, as we move up the scale of the Zia factor, we're moving down the scale of how long our cold lasts. So as one's going up, the other one's going down. And that's a negative correlation. Negative correlation. One way to see that is once you draw your line of fit here, this line, if it's a negative slope on your chart, then it's a negative correlation. If it's a positive slope, then it's a positive correlation. All right, so now let's take some examples. Let's identify the correlation of the following three items. And our answers can either be positive, negative, or none. That means positive correlation, both sides of our data set are going up at the same time, or negative correlation, one side's going up, one side's going down, or none, I can't really tell what's going on. All right, so let's take a look at this. Let's go with the red line here, the population of a state and the number of representatives. Well, we know that as the population gets bigger, we go to like states like California, they have the most reps. And in a state like Iowa, population is kind of in the middle, a little bit on the low side, and we're going to have fewer reps. We know if you followed up in your social studies class, in your civics class, you know that as the population increases in a state, they get more of the allotment of state representatives to go to Congress. So this chart would look something like this. I'm just making examples of the data. And if we drew a line of fit, it would look something like that. And we'd be very strong correlation. So this, and you'll notice that it's going up. Both things are going up at the same time. So I'm going to give this a positive correlation. All right, let's look at the second one. The population of a state. Well, we already did that. We know that the population of a state is going to go right here, go up as we go to the right, and the number of senators. Well, we go back to our civics class, and we know that every state, no matter what, gets 2 senators. So as our population goes up, I'll put some data points out here. Here's my state population, but my senator is always going to be 2. So if this was the line for 2, no matter what population I have, all my points are going to be along this line. Okay? And that's a flat line. And when you have a flat line, you can't say one goes up and one goes down, or you can't say they both go up, because the second line doesn't go up. Okay? When they're always 2, that's not moving at all. So you have to say, in this case, that we have no correlation. And now, let's take a look at the population, the third example, the population of a state again. Once again, we know that. We're going to go left to right, getting bigger and bigger and bigger. And the number of senators, this time, instead of just number of senators, it's per person. So let's take a look at that. If I had, I'm just going to do some quick math here. If I had a state with, just using small numbers, 100 in population, and I have 2 senators, that means I have 50 people per senator. Now if I go to a really big state, I did that backwards, upside down. Let me do that again. I shouldn't have done, there we go. I should have said number of senators to the population, and that's going to be 0.02, small number. But if I go to a state with even more population, that's 0.002. And so as my population gets bigger, this number and this number, as it gets bigger, my number of senators per person gets smaller and smaller. So this is going to look like this is going to look like data points like this. And I'm going to draw the line. Once again, let's get that in there. Oops, one up. And draw the line. And this will be a negative because we're going downhill. We have a negative slope, negative correlation. All right, well, let's look at another use of a scatter plot. Let's make a prediction based on a scatter plot. All right, so in this example, we're talking about a person's grade based on how much time they study. And we have some data points, and you can see here, I'll make this a little smaller so I can write a little better. You can see here that if you study 1 hour, your grade from the data point was about a 68. If you study 2 hours, your grade looked to be, or sorry, this is 3 hours. Let me erase that and put it back to 3. If it's 3 hours, then it looks like your grade is about 75. If you're 5 hours, your grade looks to be about, what is that? That's 80. And you go all the way up here to 9 hours, your grade looks like it's about 95. And then the last here, we got 12 hours, and they got a 98, I think. All right, so that's our data points. We drew a line of best fit. Just remember, you just grab your ruler and try to draw a line, a straight line that gets as close to all the dots as you can, and just kind of balance it out if they're not quite straight. We're being asked to predict what grade would we get if we studied 10 hours. Well, to do that, I'm going to use my handy dandy line tool again, and I'm going to go to 10 hours. Oops. I'm going to re-invoke the line tool. I'm going to go to 10 hours, draw a line straight up, and then draw a line straight over. Looks pretty straight, doesn't it? And I'd say that looks like I am going to get about a 95%. Okay? Based on how you drew your lines when you did the data, you may get your line of best fit might be a little steeper than mine. Everything might be a little different, but you're going to get something along those lines. Pretty close to 95. Okay, so we've looked at a scatter plot. Let's recap a little bit. We go back to the top here. Remember that a scatter plot shows us relationships between two sets of data. And we could see that when we looked at the logins and the Zia count on the logins, that we could see that we ended up with a line that kind of shows us something pretty logical. If we take the logins with the most Zia medicine in it, that our cold is reduced by the most time. So we got a negative correlation because as we got bigger with our Zia count, strength of our lozenge, our effect on the number of days in having a cold went down. So we had one item going up on our data set and one item going down. And so that was a negative correlation. And remember that correlations just describe the type of relationship between two data sets. The line of best fit is the line that comes close. Just use your ruler. Don't worry about getting it perfect, but use a ruler that looks good. And what types of correlation do we have? We have positive correlation. We have negative correlation. And we have no correlation. When I have a correlation of some type, either positive or negative, I may have a strong or a weak correlation based on how close I am with my data points to the line. And that's strong or weak negative correlation, strong or weak positive correlation, or no correlation whatsoever. And that is basically the end of the lesson.